Okay, I think we can get started. Yeah. So today's class 4, we'll be doing quadratics and polynomials.
I can't see your screen. Like, I don't know if that's just on my side, but I can. Okay, wait, never mind. I can see it now. Sorry, my.
Okay, yay. Yeah, so today we'll be doing quadratics and polynomials. Do you guys all know what a polynomial is?
Is
Yeah.
that the multiple, like the x squared plus 2x plus 1 or something? Is that a polynomial?
Yeah, that's a quadratic, which is a specific
Yeah.
kind of polynomial. Yeah. So basically, a polynomial is a function with more than two terms. So, well, a monic polynomial is still a polynomial. So, yeah, but like every term is like a non-negative power of the variable. So, like usually the variable is x, right? Although there can be more variables, usually it's just x. And then every term is like a power of x. So for example, x squared, x cubed, or x to the 0, which is like 1. So that's where the constant comes from. So for example, x to the 4th plus 3x plus 2 is an example of a polynomial. But the important thing is that the power has to be like an integer. So like x to the 1/2 or like square root of x, that's not a polynomial function. And then a polynomial has a degree of the variable with the highest power. So like for example, x to the 7th plus 4x to the 4th plus 9x minus 4 has degree 7 because x to the 7th has the highest degree and the degree is 7, right? So if it was like x squared plus 3x plus 7, then the polynomial would have degree 2 because the highest power of x is 2. And then, so these, oh, you guys want to go over the homework? Oh, sure, we can do that. Do you guys have any specific problems from the homework? I can like pull it. Okay, hold on, let me put it on. Okay, yeah, can you guys see the homework?
Yeah.
Okay. Um, yeah, sure, we can go over like the first couple. So for question 1, would anyone like to share?
Yeah, I can.
Yeah, go ahead.
Just give me a second. Sorry.
Mhm.
1 sec. Okay. Yeah. So the difference is that the codomain, it's like the set of all the possible outputs. And the range, it's like the set of the actual set of outputs that are like reached or achieved by the function.
Yeah, exactly. Okay. What about question 2? I can explain it if no one wants to. Yeah, so the domain is all real numbers, right? And then the codomain would also be all real numbers. And the range would be the same as the codomain in this case because all the numbers can be reached because like it's just a line, right? So you can reach for all the values on the x-axis, you can reach all the values on the y-axis. Because like the line goes on from negative infinity to infinity. So the range would just be all real numbers.
So the domain, codomain, and range are all three all real numbers.
Yeah, for question 2 it is. Okay, what about question 3? Would anyone like to share? Okay, yeah. Question 3 is a bit tricky because 1 over x is not like a very nice function in terms of like polynomials because it's not a polynomial, right? So if I can like, let me see. If I can graph f of x, can you guys see that? Sorry, I'm doing this with my mouse.
Yeah.
Yeah, so the graph of f of x is kind of funny. It's like this. Because for like positive x that's greater than 1, then as x increases, 1 over x decreases, right? It like decreases all the way to 0. For example, if you go from like 1 over 2 here all the way to like 1 over 100 here, 1 over 100 is going to be smaller than 1 over 2. But even as you keep going for x to infinity, it's just going to like approach 0, right? So that's why it's like decreasing and decreasing here. But for fractional x, as x gets closer to 0, then 1 over x it gets bigger, right? So for example, here, if you have like 2/3 and 1/3, 1 over 2/3 is going to be smaller than 1 over 1/3. And then that continues. So this part is going to go bigger and bigger and bigger all the way to positive infinity, basically. And then it's the same thing for negative, except, yeah, basically everything's negative. So it'll go from negative all the way approaching to 0. And here it'll keep like decreasing all the way to negative infinity. But you have to note that here, no value of x here will give f of x equals 0. So 0 is not part of the range of f of x. Does that make sense? So basically the domain would be all real numbers. The domain and the codomain would both be all real numbers, but the range would be all real numbers except for 0. Yeah. Okay. Um, yeah, we can go over problem 4 too. Would anyone like to share? Okay. Yeah, so for problem 4, we have to find f of g of x. So g of x is on the inside, right? So we go from inside out. So we do g of x first. So if we plug x into this function, then g of x will give 3x. So that's the result that we plug into f of g of x. Because basically, g of x is the same thing as 3x. So f of g of x is the same thing as f of 3x. Does that make sense? Because, um, let me draw here. So g of x is replaceable with 3x. So in here, in this inside, We can replace g of x with 3x. That's
Okay.
basically what the function is doing, right? Because g of x is
Okay.
3x. So then we're asked to find f of 3x. And then we just plug 3x into here. So 2 of
Join to watch it.
sorry. So 2 times 3 of x is just 6x, and then 6x plus 5. So f of g of x is 6x plus 5. Yeah.
Can you explain problems 9 and 10?
Oh, problems 9 and 10? Sure.
Thank you.
Okay. So yeah, problem 9, I don't think we really covered this in class. We didn't really, yeah. So it's fine if you didn't really know it. So basically, what this means is basically f and g are inverse functions. I think we might cover that in another class, so it's fine if you guys don't really know. Basically, if one function does something and then the other function does the opposite, then they cancel out. So then it'll be the same thing. Yes. Yeah, that's one. Inverse of functions is one condition, and there are actually like a lot of conditions that would work. But if they're both the same, then yeah, because like f of x plus x is the same. Yeah. I think it's supposed to say if f of g of x equals g of f of x equals 1 or maybe x, but that was in a different version. So yeah. We might cover this in another class, so don't worry if you don't really understand it now. For question 10, yeah, so question 10 is a little tricky. So we can start with f of x first. So f of x just has a slope of -3, right? So this part is -3. Wait, do you guys know? So if I have a line with a slope of like -3 and I add it to a line that has a slope of 2, then the resulting line has a slope of -1. Does that make sense?
Yeah.
Okay, yeah. So here we just ask the slope of this, so we can just replace this with the slope of each one individually and add it. So this has -3. So for f of x has a slope of -3. So um let's see. So f of x has a slope of 9 because it'd be -3 times -3.
Okay, yeah,
Right?
that makes sense. Yeah. Thank you.
Okay, yeah. So if that makes sense, then you can just put 9 here. And then this one would be the same. It'd be -3 times -3 times -3, which is -27. And then you just add that to get -21. Yeah, the main thing is that f of x has a slope of -3 times -3. If that makes sense, then that's good. Okay. Are there any other homework problems or? Okay, great. Um, yeah. So today we're doing quadratics and polynomials. Yeah, I think I pretty much covered this slide already. It's just like the names of these things. So this entire thing, like with a variable, is called a term. And then if there's no, if the power, so like technically this is times x to the 0, because like it's a non-negative power of x, but x to 0 is just 1, so we just leave that off. So if it's if there's no x, basically, it's called a constant. And then these, like something times x, this like constant number is called a coefficient. And then so this number 5x squared, it's by x squared, which is like the greatest power, right? So usually they're written in order from greatest power to least power, like here. So then this one would be called the leading coefficient because it's the one in front. Yeah. And then, yeah, this is pretty much it. Sometimes the leading coefficient will be negative, which is pretty interesting, but we can cover that later. Yeah. Are there any questions on this slide? Okay. Yeah. Okay, so the domain and range of a polynomial is pretty interesting because it depends on if the leading coefficient and it depends on the degree of the polynomial, right? So the degree we said earlier was like the greatest power of x there was, like x to the 7 or x squared, if it was the greatest power. So it depends on these two things. So if P has even degree, for example, if it's a quadratic, or if x like to the 4 or x to the 6 was the greatest power, then it has this funny W shape. Actually, the parabola also has the W shape, but like just no humps in between, I guess. But usually they have like this W shape. And then if P has odd degree, then it has like this sideways S shape, right? So like if it was x cubed or x to the fifth as the greatest one. And then, so basically if the leading coefficient is negative, then the polynomial graph is like flipped across the x-axis, right? So like for example, for this one, oh, no. So like if you have like a quadratic with a positive leading coefficient, it usually looks like this, right? But with a negative leading coefficient, it usually looks like this because like it's flipped, right? So then it's the same with all these other polynomials. So what that means is that for even degree polynomials, you don't necessarily know the range, but you know that it's not all real numbers because both sides will go to the same infinity. So like everything here is not part of the range. So it's not all real numbers. But for odd powers, it definitely is all real numbers no matter what, because each side will go to a different infinity. So like one side will go to negative infinity and one side will go to positive infinity. So every number in between is covered. So the range is always all real numbers. Okay, are there any questions? Oh, a polynomial we covered here is like a function where every term is a power of a variable, is an integer power. So like a quadratic, like x squared plus 2x plus 3, that's one example of a specific type of polynomial because the power of x is like 2 or 1 or 0. So x squared would be like a highest power of 2. But there's also other functions with higher powers of x, such as like x to the 4 plus 3x plus 2. That's also a polynomial because it has a power of x. That's like an integer.
So then what are monomials? Like, are they like,
Oh, monomials are a specific type of polynomial, but only has one term. So like x to the 7 or 3x squared, those are monomials.
oh, okay, thank you.
Yeah, so they're not polynomials because there aren't multiple terms. Monomial means like one term.
Binomials are like with two terms, right? Like x
Yeah,
squared minus 7.
Yeah, and then
Like,
trinomials are three terms. So you could say like a quadratic, like for example, this quadratic here is a trinomial because it has three terms, like a quadratic trinomial. And then if there are only two terms, then it's like a quadratic binomial. But yeah, monomial means it's only one term. So like if it was just this, then that would be a monomial and not a polynomial. Yeah, so usually they only have one term. Oh, so basically, do you guys know when you're like graphing a function, it's like y equals something something x? So basically, that's kind of what they're doing. You just move the y to the other side, and then it's just like you graph it. Does that make sense? Um, yeah, so in this example, like if you were to graph this, then you'd probably say this equals 0, and then you'd move the y to this side and divide everything by 2, and then you'd graph it. So then y equals like, I don't know, 5 over 2x squared or something like that. And then, yeah, basically. But usually you would just see one variable. It's like a lot more common. Yeah, great question. Yeah, exactly. Um, yeah, so did this slide make sense? Like about the range of the polynomials? Okay, great. So for quadratics specifically, they're in the form of ax squared plus bx plus c, where a is not 0. This is important because if a is 0, then it's just a line, right? It's just a linear equation. And then a, b, c are constants and x is the variable. So there's usually just one variable. And then to solve a quadratic, it's just like when you solve a quadratic equation, usually the quadratic equals 0, and then you find the roots. So to solve a quadratic, you set ax squared plus bx plus c equals 0, and then you find the values of x that make it 0, and those are the roots of the quadratic. So when you graph it, so you guys know how 2 points determine a line, right? Similarly, 3 points determine a quadratic, and then like four 4 points determine one with x cubed, and then 5 points determine one with x to the fourth, and so on, right? But 3 points determine a quadratic. So if you find roots, and if you find like two roots, because a quadratic has at most two roots, if you find two roots, say here and here, that's not enough to determine the graph of the quadratic. You need one more point. So usually it's the y-intercept because that's like pretty easy because the y-intercept is just c, right? Because x equals 0, so there's just c left. Or you can find the vertex of the quadratic, which in some forms is like pretty easy. But if you have 3 points, then you can determine the unique graph of the quadratic. With 2 points, you don't know. So you need at least 3 points in your graph, and then you can just sketch the parabola, and then, yeah. Oh, a parabola is, oh, sorry. A parabola is just what the graph of a quadratic, the shape of a quadratic is called. So like, you know this like funny shape? Sorry, I'm drawing with this with my mouse. But yeah. So like the shape of a quadratic, like this U shape, that's called a parabola. Kind of like this shape is called a circle, like that shape is called a parabola. Okay. That's a really interesting question, but I don't think so because um a polynomial's graph is like always curved, right? But a polygon has straight edges, and no part of like a polynomial's graph is straight. It's all like curved lines. Yeah. You can use like lines to graph a polygon, but I don't think you can use polynomials. Yeah, you can't use polynomials. Circle. Hmm? Oh, like if you can use a polynomial to graph a circle? No, because the curve, like the arc of the curve is not the same arc as the circle. If you guys know how to like graph a circle, it's actually made up of two quadratic polynomials. But oh, so like the arc of a circle is not the same arc as like a polynomial because the arc of a polynomial is not constant all the way around. Do you guys know where this polynomial is from? Like conics? Maybe you should cover that in another class. Okay, it's pretty cool. So basically, it's like, do you guys know a cone? Yeah, so if you like have a cone, right? And then you cut like something parallel to the base of the cone, you get a circle. But if you have a cone and then you cut a slant, that's like a parabola. Wait, is that a parabola? That might be a hyperbola. Okay, wait, if you do the slant, that's an ellipse. And then it's like if you have like two cones, one right side up and then one upside down, and then you cut it like this. So wait, I should cover that in another class. There's like 6 basic shapes you can get from cutting the cone. It's like circle, hyperbola, ellipse, line, and parabola. And I'm missing one. Yeah. And let me see if I can like pull up a picture. Wait, yeah. I don't know if you guys can see that, but like that's where these come from. So like if you do it parallel, it's a circle, do it slant, or like if you do it past the other cone, this is like where these shapes come from, basically. And then that's how you get like the equations for the shapes as well. Oh, so a hyperbola? Wait, let me search up another picture. They are quite similar actually, but hyperbolas are like more annoying in my opinion. So they're defined differently. And so a hyperbola is like mirrored. So there's like 2 of them, but a parabola, there's just one. And then, yeah, if you guys can like see that. They're like defined slightly differently. And then a parabola, it will like go for all x values, it will reach all the like positive y values or negative y values. But hyperbolas have asymptotes. So like they're like, you
They'll
know.
like never touch zero, right?
Hmm?
They'll never touch zero, right? The hyperbolas, because they
Oh, well, They can be shifted so they do touch zero. Like if you shift the entire graph up by some number, it can touch zero. But there are some numbers that they don't touch.
Yeah, okay.
Yeah. Yeah, quite similar. Okay. Yeah, exactly. Yeah, great questions today. But should I continue? Yeah.
Yeah.
So for a quadratic, to like solve a quadratic, usually, well, you always have the quadratic formula, right? So like this is like the hammer, like all quadratic equations you can use this formula to do. But for some equations, for some quadratics, it might be easier to like factor or like complete the square. So usually you can factor it. So this is like the factor form of a quadratic. So where r and s are the roots, right? Because if you plug in x equals r or x equals s, then this equals 0. And then if you expand that out and to get like the normal form of a quadratic, like x squared plus bx plus c, you get that r, negative r plus x, actually this negative is very important, is equal to b, and then this r times s is equal to c. Do you guys get where this comes from? Basically, if you like factor the quadratic and expand it out, these are the relationships with the roots. So actually there's a similar relationship for like all the polynomials. You just factor it out yourself and then you can like find it. Or they have a name. They're like, it's a pretty recent name, but it's like Vieta's formulas. You guys can search that up if you want. But yeah, it's basically what it basically is just a factor like relationship with the constants. It's the negative for, but the negative is for both. So basically, you have to have x minus r if r is a root, right? So if like 3 is a root of the quadratic, then x minus 3 is a factor, not x plus 3. Because if 3 is a root, then that means if x equals 3, then the equation is 0. So if you have a factor of x minus 3 and x is 3, then that factor is 0, so the entire thing is 0. That's why it's 0. So r is a root, and then x minus r is one of the factors of the quadratic. So when you expand this is like negative r times x and negative s times x. So it's negative r and negative s.
When I leave it,
Yeah, exactly. Yeah. But if it's not easily factorable, then you always have the quadratic formula, right? Have you guys learned that yet? Yeah. And then this part is because a quadratic always has two roots, but they're not always real roots, right? You can have 1, 2, or 0, 1, or 2 real roots. So basically, it depends on this part because you can't you can't square root something negative and get a real solution. So basically, if this part is negative, then you get this part is imaginary, and then you get two imaginary solutions. If this part is 0, then you get 1 because plus or minus 0 is the same thing. So it's the same root. And then if it's positive, and then you get two real solutions because you can plus or minus something different. So you get two real solutions. Yeah. Um, Oh, so if you guys don't have like two real solutions, then when you graph it, it's probably not gonna pass over. Well, if you guys don't have two real solutions, then it's not gonna pass over the x-axis. It's probably gonna like look like this, but it's not gonna like intersect the x-axis, like the lower one. So like this one would have two real roots because it passes over the x-axis twice, but this top one would have zero, right? So if you graph a problem with like no real solutions, then you can't use the roots to graph. You'd have to find like three different other points. Yeah. Okay. For polynomials, yeah, I covered this earlier. The even degrees have like this W shape, and then the odd degrees have this like sideways S shape. And then, yeah, the shape depends on both the degree and the leading coefficient. So for solving a polynomial, unfortunately, there's no generalized quadratic equation for polynomials. There actually is one for cubics and quartics, I think, but it's not really useful for like us, only for like machines, but like not really for us. So yeah, basically you can't really use the quadratic equation. So usually if you're asked to solve a higher degree polynomial, there's usually something special about it. Like it can be factored easily, or it's a product of two like easily findable smaller quadratics. But yeah, you can't just find the roots directly. Okay, I have some of these practice problems. I'll give you guys about 10 or so minutes. We'll see, and then I'll go over the answers. Yeah. Oh, so when it asks you to sketch a polynomial, it basically means that you have to find like three or however many points you need for the polynomial. And then, so you have to find the points. And then, since we're doing it online, you can just like tell me the points. But usually you just graph the 3 points and then like sketch a rough shape. Yeah. Okay, I'll give you guys about 10 minutes or so to do it.
मम्मा मेरे को कुछ खा
It's been about 10 minutes. Do you guys want a bit more time or should I go over some solutions now? Okay, I think I'll start explaining the solutions now. I think Sashi, you wanted to explain number one?
Um, yeah. So first, I use the discriminant, which is b squared minus 4ac, to figure out how many solutions there were. So in
Yeah.
this case, I just assumed that b was 0 because since the x then gets removed. And
Yeah,
we know
B
that
is
a is going to be 1 and c is going to be -4. So now you just input that into the function. So it'd be 0 squared minus 4 times 1 times -4. And then if you simplify that, that's 0 plus 16, and then that equals to 16. So since it's greater than 0, we know that there's going to be two real solutions. So now we can actually add the other numbers. So it would be negative b plus or minus square root of 16 over 2a. So since b is 0, it'll just be 0 plus or minus, and then the square root of 16 is 4, so plus or minus 4. And since a is 1, it'll be divided by 2 times 1, so divided by 2. So now 0 plus 4 is 4. So 4 divided by 2 is 2. And then 0 minus 4 is -2. So is -4. So -4 divided by 2 is -2. So the answer is -2, and 2 are the solutions or the roots.
Okay, yeah, that works. Yeah, for any quadratics, you can always use the quadratic equation and it'll always work. Another way you could do it is to like factor because this is difference of squares, right? Because x squared and 4 is 2 squared. So then by difference of squares, you know that this is x plus 2 times x minus 2. So then those are your roots. But yeah. And then you would, if you graph it, you'd graph f. Actually, I'll just do it. It would be like roughly, you have like -2 and 2, and then you can input one more point. So like if you have x equals 0, then this is -4, and then it's gonna look something like that. Oh, okay, but yeah, you guys get the point. Okay, what about for number 2? Okay, yeah, I can explain it. So for this one, you can also just input the quadratic equation if you wanted. This one's also like pretty easily factorable. This one is x plus 1 squared. Oh, this does not work. X plus 1 squared. So like for a lot of quadratic factoring things, they're usually like these pretty standard formulas, like pretty standard forms or patterns that you can look out for. Because most of them are going to be some form of difference of squares or product of squares. So yeah, and then you just, oh, for graphing this one, since there's only one root, it's only gonna touch the x-axis, but it's not gonna intersect it twice. So it's gonna intersect at -1, right? Because if x is -1, then this is 0. So Yeah, I should probably put more points than this, but it's just gonna like touch the x-axis like that. Yeah. For number 3, okay, this one's not exactly a good form, but basically the important thing is that you can't just divide x on both sides directly, because if you do that, then you'll miss a root. Because if you divide both sides by x, you disregard the condition when both of the x's are 0, right? Because if you divide both sides by x, then you just get x minus 1 equals 0, so x equals 2. But actually, x equals 0 is also a root. So probably what you want to do is factor it first, x squared minus x equals x, and then x squared minus 2x equals 0. And then you can factor out when they're all on the same side. So then you get the two roots are x equals 0 and x equals 2. Yeah, and then you just graph it normally. Yeah, what about for the last problem? It's pretty much the same thing as earlier here, right? But this one is actually a cubic, so it's the form of x plus 1 cubed. And then if you want to graph it, it's quite a bit more complicated. So for quadratics, the power is 2, right? So you need at least 3 points to determine a unique quadratic. But for cubics, the power is 3, so you need at least 4 points to determine a unique cubic. And then here you only have one root, which is x equals negative 1. And then even if you have the x-intercept, which is 1, and then you just have to plug in a couple more numbers for x. Like if x equals 1, then this is 6. So like maybe up here. And then if you have x equals negative 2. Oh, do I want to do that? Oh, negative 1. Okay. So here. Um, Probably it's something like this. I should redraw that. So like a somewhat sideways S shape, if you guys get what I mean. It should be this way. Yeah. Are there any questions on any of the problems? Oh, okay. Okay, great. If not, we can end class now. Homework will probably be posted tomorrow. And yeah, good night.
Thank you. Bye.
Bye. Thank you.